So, hello everyone, my name is Vikas Soni and I welcome you all in this lecture 2 of my DP series. So, in this video, you are going to learn about 1D DP in advance. So, in the first video, we talked about basic DP, what is the intuition of DP, and solved some question like what is the DP, how is DP applied in question, and how to find if the DP is applied. So we talked about DP versus greedy idea and solved some fundamental question and talked about important concepts like memoization, tabulation, and finding the time complexity and many things. So if you haven't watched the first lecture and you don't know exactly what a DP is, like you don't get the intuition of the DP, then you should watch the lecture 1 first. So now in this video we are going to learn about this 1DDP in advance. We are going to solve most of the questions, and so first of all we are going to cover all of the fundamental types of the 1DDP. Then we are going to learn how to solve the non-fundamental question, how to find their states, and then from states how to make the transitions, and after that also we are going to learn about how to optimize this step. So again, we will solve them by memoization, tabulation, and also a new concept which is how to reduce the space of DP, right? So you know that for DP we make the vectors and we store all the value in all of the tables, but you will see that we don't need the tables every time. And after that we are going to solve some important question. So some of them are going to be fundamental, but others are going to be non-fundamental code forces question from easy to moderate. So that is it. So now I hope that you know what is 1DDP because we talked about it from the first lecture. So let me just see what are its type. So DP can so the 1DDP can be reduced in mainly 2 or 3 types. So okay, let me write here the types. So the first type is when you have count something. So it is, let's say, counting ways. So let's say you are given some data and you have to count something, let's say how many ways you can reach n, or how many ways you can do the work, or something like that. So let's take a important example. So the example is like the frog jump question. So it is that the can jump frog can jump 1 or 2 tiles, and you have to find the number of ways such that frog can reach the nth tile, reach the so this is a nice question. Nth tile, oh, it was not tile, it was stair, but that doesn't matter. So how we are going to solve this question? Can anyone think of it? I hope that you can solve this one. So just a second. Okay, so this is nothing but yeah, we know that we have solved this in the previous question. So dp of I is going to be number of ways to reach height tile, and then the transition is going to be just dp of I is equal to dp of I minus 1 plus dp of I minus 2. That's it. So when you have to count, you will just see all of the possible ways and you will just add them up. So that was it. So now let's say what if our frog can jump 1 tile, 2 tile, and 3 tile also. So what if our frog can jump this 3 way? 1, 2, and or 3. So now we just have to add the dp of I minus 3. That's it. So this is how like we can make the transition, and this was the question about counting something, right? So when you have to count something, you know that. So what you will do is that you will just sum up all of the possible ways you can reach something, or you will just sum up all of the possible ways to do the work, something like that. So this is it. Now the other ways, like other type is you have to find some minimum or maximum cost of something, right? So let's again take the frog jump question. So the question is again the frog jump, and this time you can jump one or two tiles, but now instead of all of the possible ways, you just have to find the you just have to find the okay, let's say the minimum cost to reach nth tile. So now in this the question is something like there are n tiles uh, in the starting. You are you're at the zeroth tile, you're at this tile, and every tile has some cost. Okay, so let's say the cost are something like this. Yeah, that's it. Let's have just pattern. Okay, and the thing is that you are at currently this tile, and you can jump one tile or two tile, and then let's say you come at this tile, then you come at this tile, and then you come at this tile. So the cost is going to be just the sum of the tiles. So sum of the cost at that tile. So it is like 5 plus then the second one, then you are at third one, and then you are at sixth. Then the cost is 6. So it is going to be just sum of everything. 5 plus 2 plus 3 plus 6. But instead of this, you can also do something like you jump here and directly you jump here. So in this way, the cost is going to be 5 plus 1 plus 6, which is the best way in this, right? So now you have to find the minimum cost to reach the nth tile. So again, what will you do? Just think for some time, and that's it. So like how we how we just like when we have to count all the possible ways. So the state was like the number of ways to reach ith tile. So something like this, similar to this. What should be the state in this? Again, you can see that the greedy is not applied in this question. Like you can try to think of greedy way, then you will see that the greedy is not applied, and then you have to think in the DP way. Then you will see that to count the data or count the answer for let's say ith one, what data you need, or what is something you need from the previous things, right? So the one thing is we know that let's say because we know that we can jump only this one or two tiles. So let's say you want this thing, right? You want here that what is the minimum cost to come at this one. So we know that only the important things are this tile and this tile, because you can jump from here or here, that's it. So you need some data of this one and some data of this at this one, but what do you need? That is the question. So this is easy that you just need the minimum cost to reach some ith number. So let's say the state is like dp of I is like the minimum cost to reach ith time. That's it. And now what how are the transition are going to look like? So the transition are easy. Sorry. transition are going to be like simple. It is going to, let's say you have only two possible ways. So you know that you can come here from the I minus 1th tile or I minus 2th tile, right? So there are only two possible options. The dp of I minus 1. So this is the cost to come at till I minus 1th, right? So you come at I minus 1th tile with the minimum cost, and then you you come at this ith tile. So yeah, again the cost of ith tile is going to be added. So this is the one option, and the other option is you come till I minus 2 tile, and then you just jump two tiles. So again, this is so these are the two possible ways. Now which one will you select? Of course, I will select the one which is the minimum one. So the answer is just the minimum of these two things. Again, this cost is the same in both, so I can write it as minimum of dp of I minus 1 and dp of I minus 2, and I just took this cost of I outside. So that's it. So this is how our transition is going to be look like, and that's it. So now let's like so I hope that you can understand this thing. So right, the thing is that I need some minimum cost to reach something, and again from all of the possible ways, what is the thing I need? I ask this question to myself, and so like the first thing is to get the answer for this. I only need to care about these two. But what data I need from these two? It is nothing but the minimum cost to come at this way. Right? So like there can be many ways. So let's just see how many ways there are. Sorry, to come at this one. Right. So there is one way is like you directly jump from this 5 to 1. You directly jump this. So the cost is going to be 5 plus 1 is equal to 6. Then the other way is something like you jump here and you jump here. So the cost is going to be 8 in this one. But we know that if I have to come to this ith tile and there are two options and I need the minimum one, I will never use this one option because there is a better option here. I will never use this one. So I will just remove this thing. Alright, that's it. So I will only care about what is the minimum option. So all of the other irrelevant ways are going to be just uh, deleted. That's it. So that's how I count. So let's say let's I just try run the DP in this. So let's make the DP. Now this is the 0, 1, 2, 3 and the 4th. These are the DP values. So now when I am at 5, I know that there is only one option which is going to be 5. That I am at this first tile. If we are just seeing zero based indexing. So to come at this 2, the only way is come from this 5 because there is no one 2 tiles away, so you can come. So there is nothing. There is only one way is that you come to this 2 is you come from 5. So the cost is going to be 7. Now comes the important part that you have to come till 1. So you will just see sorry, you will just see the two parts or two ways, which are you can come from this 5 to 1. What is the cost? The cost is going to be, let's say this one, this 5. So the cost is going to be, so to come till this 5, the cost is 5. And from this you jump and come here. So the cost is 5 plus 1 is equal to 6. So one way is 5 plus 1, and the other way, the second way is you come from this 7, this 2. You come from the first tile, which have the cost is equal to 2. So you just come till here. So when you have to reach the first tile, the cost is 7. And then you jump here. So the 7 plus 1 is going to be 8. So it is 7 plus 1, which is 8. But now we will just see the the minimum one. So the minimum one is 6 here. So the cost is going to be 6. And you know that it is not increasing, right? Like, just see here. The cost to come till this second tile is lesser than the cost to come at this first tile. So that's it. So you can't have some greedy way. Now when you come at this third tile, which have the cost is equal to 3, the answer is just this minimum from this 2, which is 6 plus this 3. So 6 plus 3 is going to be 9. And then here it is going to be the minimum of this 2 plus 6, which is going to be 12. So that is the answer. So the minimum cost to come till this fourth tile, the last tile, is 12. And what was the path? So the path, let's say you have to find the path. So it is just you are at the sixth one, then you come here, then you came here. That's it. Okay, that's something. This is the path. So just looking at this path, you can say that, hey, I can see that this can be greedy. We are just jumping 2 tiles, but this is not the case. Let's say if the cost was 100 here, then you will see that this cannot be done with greedy. So that was it. So that's how you just make the transition. So first you have to care about state. You have to find about state, then then you have to do some transition like this. Now why not I just change a small thing. Let's say the thing is all same. You can either jump 1 tile or 2 tile, but let's say that it's something like let's say when you jump 2 tiles, there is some extra cost you have to give. Let's say that extra cost is equal to e, right? So when you jump 2 tiles, let's say the extra cost is equal to e you have to give. That is the case. So again, this is going to be easy. So like we have the transition, we will just write here. So we know that the dp of I is going to be that you come from the I minus 1. So the cost to come to this I from I minus 1 tile is this one plus the current element, or the cost of the current element, or so this is the minimum, or you come from the I minus 2. So you just give the cost to come till I minus 2. So you come at I minus 2 with the minimum cost possible, then you give the extra cost e, and then the cost of current one. So that's it. This is it. So that's how the easy the transition are. So you just have to find what all the possible ways, you, all of the possible ways you come till I, and then uh, what is the cost to come from this thing, and you will just in this you will just greedily take one thing, right? So let's say if like in the brute force one, what you do is that you take all of the ways, but in this greedy we just take, like if you have to come till I just take the minimum path from this two. That's it. So that's how this dp works. And the transition are going to be very easy. The main thing is about state. So this was the second type of this 1D DP question. And again, like there can be some also decision based question, which is the type 3. Let's say this is not the main. What if you have to just find the max cost? Again, this is easy. You will just remove this min. You will just remove this min and write here the max. That's it. So the type 3 is like some decision based question. So like in the type 2, we just see here that you have to decide whichever is the best way you have to take, and from this you just you just decide something. So this is also like, let's say instead of min max you have some other things, uh, but I you will see in the question. So that's it. So that's where the main most famous two ways or two types of the one DDP. One is you have to count something, and that comes many times in the combinatorics question. So this is important one. And the second one is this way. So like in this type of question, you have to think if greedy is applied or not, and then you just see the if the like DP is applied, and then you have to find the state and transition, and also you have to care about base case and write the code. So that was it. So like I don't have the link of this question, but let's just code of this. I think that will be better. Okay, so what is this? Sorry for this. Base std++.h. So let's say we are given one array. So let's just take and think that its size is n, and let's say this is the cost array. Okay, so let's say we are just given the two things. We are in this vector cost, and I know that the cost, if I come to this ith tile, what is the cost I have to give? That's it. So like now I have to what I have to do is I have to find the max minimum, right? So let's say I make the DP of this, DP of size n. So this DP, and here, this is a good approach that whenever you just make some DP, you just write what are the state, what is the state is in your DP array. So like whenever you are just seeing your code again, or when someone else see your code, it is better to understand what is the DP thing doing. So the DP of I, in this one, the DP of I will show me the min cost to come till ith tile. Now we write the base case. Base case. What is the base case going to be? Which is just that when you have to come till this zeroth tile, the cost is just this one. That's it. And now you do the transition from the 1 till the I. What are the transition? So we know that let's say the cost, let's make it dumb d cost. Yeah, d cost. It is going to be, let's say one possible way was you come from the I minus 1th tile, so which is I minus 1 plus the cost of this current one, or and if the I is let's say greater than equal to 2, then also then only you can come from the I minus 2th tile, right? So because if when I is equal to 1, there is no I minus 1th tile, so you cannot come from there. So this is the if condition you have to write, and then the d cost is going to be minimum of, so the cost initially, which was this one, and the cost which is now when you come from the I minus tooth tile, this one plus cost of I. That's it. So now the dp of I is going to be the d cost, and you have to, let's say, give the answer to come n minus 1 tile, so the cost is this. That's it. Okay, I hope this is correct. And what is the, okay, I, this is end one. So yeah, let's just take the array which we take in the example. The array was like it has 5 elements, and the cost was like 5, 2, 100, 3, and 6. So the cost is going to be 16, which is 5, then you come to 2, then you come to 3, and then you come to 6. That's it. You just ignore this 100, because yeah, if you come at 100, then cost is simply added by 100, which is a bigger one. So I hope that is correct. So 7 plus 10 plus 16, that is correct. That's it. Now let's say, as we talked about, there is e extra cost when you jump 2 tiles. So let's say that e is also given to us. So now again it is simple. So when you are jumping 2 tiles, you just add that e extra cost here. That's it. So again, all of this thing you have to think in the transition one and all of the possible ways also. So let's say the thing is like you can jump 1 tile, 1, 2, or 4 tiles. Right. Now what will you do? So again, this is again a simple one. If the I is greater than equal to 4, d cost is equal to minimum of d cost and dp of I minus 4 plus cost of I. That's it. So again, this is all of this thing like can change into transition, but it is easy, right? So you will just you are at the ith position and you will see all of the ways, so that from that you can come to this ith one, and then you just decide whatever you have to take. In this we will just greedily decide, take the minimum one, like the way which have the minimum cost. So that's it. So that is something we will do in this. So like, okay, so that was it in the counting question. And I hope that you understand this thing. Okay, I just forgot to explain one more thing, which is optimizing space complexity. Okay, so now let we just see and analyze the case when we are just counting the answer, and like see which are the, like which values of dp are when are they used, something like that. So let me just be more clear here. So let's say the cost array. So you have a cost array, the cost at c1, c2, c3, c4, and a c5. So from this you make some dp, which is just dp of 0. Let's just make this one based index. So dp of 1, dp of 2, dp of 3, dp of 4, and dp of 5. So like in the initially you have the value of dp of 1. Then for you do here dp of 2 is equal to, so like let's say in the in the first second the dp, you calculate the dp of 1, which is nothing but the cost of 1. Then at the second you find the value of dp of 2, and this thing, it is just going to be the minimum of dp of 1, and there is no one here, so that's it, plus cost of 2. Then in the third second you count the dp of 3, which is going to be mean of dp of 2 and dp of 1. Yeah, plus cost of 3. Like, just ignore this thing, just like, I am just caring about which values of dp are used when. So now let's say you just count dp of 4. Again, this is going to be minimum of dp of 3 and dp of 2 plus the cost of 4. And in the fifth second, dp of 5 is going to be minimum of dp of 4 and dp of 3 plus cost of 5. So just see here that, like, when you are counting the value of dp of 5, you only need the values of dp of 4 and dp of 3. So there is no use of dp of 2, right? When you are, like, after this second, right? I mean, what I'm trying to say is that each value of dp, so let's say you calculated this dp of 2, then it is used only the 2 seconds afterward, right? When you have to count the values of 3 and when you have count to the value of dp of 4, and that's it. After that, whenever you are counting, let's say dp of 5, dp of 6, dp of 7, and similar, like, you have no use of dp of 2. That's it. So, like, so what optimization you can do is that, let's say when you have to count the dp of 4, you just like, have the values of dp of 3 and the dp of 2 in some variable, and after this you just remove this dp of 2, you just delete this thing. You don't need to know the value of this dp of 2, because we know that the dp of 2 is never going to be used again, right? Is that right? And instead of this, so, like, let's say what I'm trying to say is that, let's say you have some book or something, like, and in this, instead of storing the whole table, you just store the last value and the second last value. That's it. So when you have to count the value of dp of 3, you have the values of this and second last, which is the dp of 1. You have these two values. Now when you after you have calculated this dp of 3 and you have to go to dp of 4, you will what you will do is that you will just delete the dp of, sorry, okay, initially you had dp of 2 and dp of 1, so you will just remove this dp of 2, right here dp of 2, right? Because now when you are at the fourth one, the second last is dp of 2, and you will just remove this and have dp of 3 here. The dp of 3 is just you calculated it now, right? And that's how you just move. Can you understand this? So, like, let's have this in the code. So instead of this table, we only care about about the last and second last use of dp. That's it. So let's say, just hope that the n is greater than 2 now. So you just have the two values, last and the second last. Now let's say that you are just at the dp of 2. So second last is no, second last is going to be, what it is going to be, the, okay, just a second, I have to think. Okay, yeah, so the only way to come till this second one is going to be cost of 0 plus cost of 1. Sorry, it is cost of 0 only. Sorry, just a second. Okay, that is cool. Okay, so like what I need to say is that like you have stored these two values, but in the base case you have to like count the some last values. So what you can do is that in the base case just count the answer for these two initially, and then by loop you are going to just get all of the other values. So dp of 1 till the first one is just cost of 1, and to come this till the second tile it is again very simple. So let's say there are these tiles, so the only way is from 1 to 2, and the cost is just c1 plus c2. So that's it. So to come till this second tile, the cost is going to be c1 plus c2. So these are our base case. So okay, this were our base case. Okay, and why I'm just using ll everywhere. It's great. And now from the second tile, like which is the third tile, because we are going zero based here, remove this. Now the cost, let's say the d cost is going to be the min among dp last and second last plus the current cost. That's it. Now we know that which was the last in this case will become the second last. The second last will become the third last, but there is no third last, so we will just delete this value. So yeah, so now the second last will become our last, right? And now our last will become the current d cost. That's it. And now when you have to give the answer, it is just the last. That's it. Like I hope that you can understand this thing, and like let's say that was it in this question. So let's say we have this 5 values, and again the values are something random. Let's just take the random things. 2, then 100, then 5, 1, then okay, did we did okay. Yeah, sorry, I just have this E also, but E is, let me just recompile it. 5, 100, and 2, 3, and 5. So 1, 2, and 5. Okay, so the answer is just 1. Then you jump 2 tiles, and then you jump 2 tiles again. Okay, that was the right answer. So that's it we did here. So instead of having the big table, I just take the two variables, and I just keep replacing those two variables and got the answer. So now my time complexity is O of n, but the space complexity okay, is going to be O of 1 only, because I don't care whatever how big the n is, I only need two variables to count the answer. So that was it in this case. So this is how you can also optimize the space. But okay, so this is it. So like, so when you have to, so like when you have a DP question, or let's say just like let's say when you have some question, let some question given. So first you have to think is if the DP is applied, or let's say if the greedy is not applied. Because in some case if greedy is applied, so then it is going to be slightly easier for you. So just check if greedy is applied. If it is not applied, then you just check what is the state of DP. What is the state of DP? Because again, like in the non-fundamental question, there can be many states. So it will depend on what data you need from the previous element source. What data you need to calculate for this one, right? So let's say you want to count the min cost to come till this one, and then from the previous things you need the data to which is the minimum cost to reach that previous states, something like that, right? And then from, so then you make the transition. So like after this you can try to make the recursion DP, but it is, which is slightly easier. But if you do the tabulation way, just try to have this tabulation way every time, and after this tabulation way you can space space optimize it, right? So like let's say just we just solved this question with optimized space. If you use the recursion way, you cannot do this, you cannot optimize the space, so that's it. So yeah, in some rare case, let's say the n is still 1e8, then you cannot make, like, then the O of n time complexity is okay, but O of n space complexity is going to be give you MLE, because you cannot have that much big array of size 1e8. So yeah, in many questions you will see that you have to optimize the space. So that's how it is good practice to code in the tabulation way in the DP. So okay, so that's it. So whenever you have some uh, question of DP, you will think in some this type of way. I hope that you understood this thing. So now this felt the like of the fundamental question of the DP 1D DP, right? So in the 1D DP, the it is something like this state. Let's say DP of I. That's it, and it is something which shows you something till this ith point, right? So the in the 1D DP states are something like that. So if the you have to count the minimum cost, it is going to be the minimum cost till ith point. If the max and max cost to come till ith point, or the number of ways till ith point, and something like that. But what if you need something extra data also, right? So let's say, like, the many times this thing is not enough. You have to see for the extra data also. So let's say uh, it is something like some war of soldier, and soldier is killing some enemies, and then you need till the DP of I, and it is something like if the soldier is killed or not, if the soldier is killed or not, or something like that. So like you need some extra data, killed or not. So you need like some extra data to get the answer of this. Okay, so for this, it is going to get into some like in the 2D way. So it is okay. So we are going to see some question of this type also, right? Okay, so whenever you will see the question, you are going to understand what I was trying to say. Okay, so let's just take some kind of moderate level question, which is like 1500 in this Codeforces. The question is that the Alex student doesn't like boredom. That's why whenever he gets bored, he comes up with a game. One long winter evening, he came up with a game and decided to play it. So you are given a sequence A of n integers, and the player can make several steps. In each step, he can choose an element of the sequence. Let's denote it AK and delete it. And then all of the other elements which are equal to AK plus 1 or AK minus 1 also must be deleted. And we need to get the maximum points we can get. That's it. Okay, you see this question. And so the thing I do is that I first try to think what can be the topic of this one. Like, can I take this with some greedy way, or something like I just take the maximum value first. I mean the maximum number first, because again this is going to get me the maximum points, right? So like, and you will just check something, but you will see that the grid is not applied. Then you will think of some DP way or something like that and get the solution. But yeah, before this, try to take some of the observation, analyze the test case and see it. Like just pause and I give you 30 seconds to solve this question. Okay, so I hope that you post and think for some time, because yeah, if you just see the solution, it is not going to benefit you much. So let's just try to analyze some of the test cases and see. So the question is boredom. Let's say the 455A boredom. Okay, so why not you just see some test case and try to solve it. So let's say the array is like 3, 4, 4, 5, and let's say it is 8. Okay, okay, let's have this test case. So like you can see that you can remove this 8, right? Because there is no 9 and no 8, no 7. So the removing the 8 will not delete anything. So it is better to just take this 8. So now our point is going to be 8 here. In this case, let's say I just remove this 4. Then this 5 is also removed, this 3 is also removed. Like all occurrence of AK plus 1 and AK minus 1 are going to be deleted. So now you can see that, like if I have just taken 1 4 and all of the other like AK minus 1 and AK minus 2 are deleted, it is always beneficial to take this 4 also, right? Because why you just take only one, right? Because if you take only 1 4 and then all 3 and all 5s are deleted, or if you take this all 3 fours and then also the all 3s and all 5s are deleted, so it is better to take all of the fours, right? So that's it. So like if it is some test cases like this one, then you just delete this set and you just take. So we got some observation here. The observation is that if if you remove, okay, not so what the observation is, okay, sorry, the observation is for each value, for each value either all its occurrence will be taken, or none will be taken. Sorry, or none, no occurrence will be taken. That's it. And now from this you have to count some answer, right? So why not we just see if we just remove that case, what are the points we are going to get? So let's say the array is something like this, 5 5 and then 8. So we will write sorry, we will write something like this is 3, so this is value, and what point it gives us. So this is 3 and there is only one occurrence, so removing this will give me only 3 points. The value is 4. There are three occurrence of 4, so the total point I will get is 12. Then there is 5. It is 5. It is going to give me the value of 10, and there is 8. It is going to give the value of 8 only. Now, again, this is the case of adjacent, right? So, like, if I remove this 4, then I know that I cannot take this 3 and I cannot take this 5 because at the point I take this 4, all the occurrence of 3 and 5 are going to be deleted. Again, like if I take this 3, then I cannot take this 4. I cannot take the adjacent element. So now it is easy. Like we seen in the house rubber problem, right? We cannot take adjacent house. So that's it. So this is as it is. Like it is just the house rubber problem, right? So what you will do is that you will make a big array, because like what is the range of the values? The range of the values are till 25 only. Now let's say that this are this something like that. Then you calculate the points you get to rob this house. It is not house, but something like this. So 0, 0, then 3, then 12, then 10, 0, 0, and 8. That's it. And now the maximum point you get if you cannot take the two adjacent indexes, something like that, right? So like as we discussed in the house robot problem, that's it. And this is just that house robot problem, and I hope that you can solve it. So like the code is homework for you. Code is homework for you. So like for in this code, just do it with also like code it with a space optimized way. Space is equal to O of 1. Do it. Try to do it in this case. And again, like as I talked here, where here, like let's say with DP you also have to you should have some other data, right? Or other case, something like that. In this one, it is also something like that. So the DP of I, and this is other, that the previous house is robbed or not, is robbed or not. So that's it. So now, like this is that's it. So you will have some table. Let's say robbed and not robbed, and 1, 2, 3, 4, 5, 6, 7, right? And this is that current house is, sorry, previous house is not previous house. It is current house. Sorry for my mistake. Current house is, and like when you are just solving by hand, you will make some table like this. So now let me make proper table, something like that. So, and you know how to solve this case, right? So let's say the values are something like 5, 6, 2, 5, 10, 11, 3, 5, something like this. So again, if you rob the current house, the value you are going to get is 5. And if you not rob this house, so I hope that you know the states. So DP of I and R or not R is going to be the maximum cost in first I houses in first I, if you, let's say, rob or not rob the current house, the last house. That's it. So this thing is going to be 0. Then if you have robbed the current house, then it is, you cannot rob this one. So it is going to be this plus the cost here. So it is 6. And if you not rob the second house, then the cost is just the maximum of these two. And yeah, just the maximum of these two. This is 5. So when you come at this 3 and you rob the third house, it is going to be 5 plus 2, 7, and 6, and 6 plus 5, 6, something like that. So, like you know how to make table, right? That's it. Okay, but now the when you have the question to space optimize it, how you are going to do that? So let's let's say when you are counting the value answer for this fourth house, what is the data you need from all of this three? What is the data? You know that you only need the values of this one, right? 7 and 6. That's it. So you can have some variable, and in this variable it is going to be the variable is something like previous and robbed and the prev not robbed. I mean just the values, you can just store the values of these two, right? So let's say when you are counting the value of this dp of 3, you will store the value of this two only. From this you calculate the value, and now the previous two values are going to be this two, and you calculate this two value. Then these two are the previous two value, you will store them only and calculate this two, and that's it. So by storing only two variables, you get the answer. So just try to code it on yourself and you will get the answer. Okay, so now we come to the interesting question, which is a nice one. I feel this is a nice question. Okay, so in this question you are given an array nums and you have to find the subarray that has the largest product and you have to return the product. That's it. Okay, just like try to solve it. If you can solve it by greedy way, like of course you cannot solve it in greedy way. Okay, pause and think for it for some time. Okay, just let me check if everything is correct. Yeah. Okay, so again, if you have to solve for DP, what is the question you need to ask? You have to ask that what is the maximum value, or I mean, what is the data you need from the previous elements so that you just count for this current one. What is the data? So like in this, what you need is the maximum product. So yeah, the first intuition is even just ask for what is the maximum data of some previous thing. But that is that it. Just think for it for a second because there are also the negative elements. Okay, so just please think because this is a nice question. Okay, so I hope that you have think for some time and let's just solve this now. Okay, yeah, in the initially let's just ask for the brute force way, because in many DP questions there is you just think for some brute force way, and let's say it is some n square or n cube something like that, and then you just like by DP you find the some way to optimize that uh, time complexity, and that's how you can get the states and values of DP or something like that. So you can also think in that way. So now, okay, yeah, and I forgot to say that you can also solve that in some greedy way, some greedy way. So yeah, try to solve that also if you can solve it. Right. So now let's say that I don't know anything, and we just see the test cases. Okay, the name is maximum product subarray. Sorry, maximum product subarray. Okay. So let's have just some of like some test cases. Let's say the array is like 2, then 5, then -2, and -6. Or let's just a smaller one, -3. Okay. How you are going to calculate the answer, or what do you need? Let's say it is 4, yeah. Okay, so let's say like we are thinking of some finding some DP way, and there can be 0 also in the array. Okay, so let's say you are just at this 5. What do you need? What do you need? So in this, why not we just see all of the arrays? Okay, so let's say we are seeing the arrays which are ending at this third position. So there are only 3 arrays. One is this one. The product of this one is 5. One is this one. The product is 10. And one is this one. The product is 40 in this case. Okay. And now you can think that, hey, I know that the I need the maximum product subarray. So I can just don't care about this two values, right? I will just delete it, and I will only take the maximum subarray product. That's it, and that's only I need to count the DP. But like then you will have some problem because there are also some negative numbers also, right? So let's say then you come here at this position, and you need to count the answer from this. So how you are going to count the answer? Like, so we are going to calculate the subarray product which are ending at this fourth position, which is -2. So yeah, one is only this one, and the subarray, let's say subarray product is here -2 only. Then you will just expand this one, right? Expand this case. So like this is 5 into -2 is -10. You expand this case. So I mean the subarray of this length 3. This will have 2 into 5 into -2 is -20, and this subarray of length 4 will have -80. And now, like, if you just see the what's let only the maximum case, you will see that okay, this -2 is the maximum. So what I will do is I will just take this maximum. I will just remove this. I will just store that the DP of 4 is equal to -2, which is the maximum I can have, and the state is like maximum I can get when the so DP of I is the maximum I can get when the subarray is ending at ith position. Something like that. But now you can see that you can see here that when you are at this minus position 3, and you just expand those all of the subarrays, like I mean you check all of the subarray. Let me remove this, and you remove all I mean all of the count all of the subarrays. The what is going to be the answer? Just -3, this is 6, 6 for the 30, and then 60, and then 64, 240. I hope this is correct. So like you will see that like uh, till this till this case, like okay, sorry, I mean Okay, let me just not reduce it. I mean, when you see this test case, see this case, and the product was, what is the product, 20 and 80, but here, like, this minus sign got removed and the product is now 240, right? So you also need to get the maximum value with this minus sign, right? Because at some point this minus sign can be get cancelled out, right? So you will see that you only not, like, you don't need the only the maximum value, but also the maximum value with this minus sign, which is nothing but the minimum value, right? So that's it. Because now you can really say that you don't have to store all of the possible, you don't have to store all of the possible ways. You only need the maximum value with this negative sign, right? And you only need the maximum value with this positive sign, or you can say the maximum value and the minimum value, right? Because let's say if there was a minus 1000, so by this minus 3 into minus 1000 you get plus 1000, plus 3000, that's it. So yeah, the minus sign can be removed at some point. So that's it. So in this value, in this DP question, you have, like, you should have the two states, right? The maximum value with positive sign and the maximum value with negative sign. So like, this is nothing but the minimum value of the subarray, right? Because the maximum value with negative sign is of course the min. So now you will have some this type of two things, and you make some table like this and calculate the answer. And how you are going to calculate the answer? Again, so let's say you have these two values, x and y. Okay, let's say these are x and y. Now how our transition is going to look like? This is x, this is y. So how I'm going to make the transition? How I'm going to get the maximum value, which is maximum subarray ending at this position 1? How do I find this? So this is easy one, right? Which is, it is going to be just the maximum of, let's say you don't take any of the subarray ending at this, I mean, you just take this value only, which is, let's say that is cost, I mean ARR of I. Because yeah, the only this value is also one subarray, right? So you only take this one, or or what you do is you take the maximum of, I mean, dp of I minus 1, and the maximum, I mean, it is nothing but this one, right? The from this previous one, what is the maximum I can get, and I take this one into, I take this current one, right? Can you understand this thing? So like, when I have this 1000 minus 1000, I will take the maximum I can make from this previous one, and I will multiply by it by here. Yeah, this is the one case. Or what I have to do is, or dp of I minus 1, and I take the minimum one, and then I just multiply with ARR of I. So yeah, if this was negative and this is negative, then I will get positive. So yeah, this also can be max. So that's it. So the dp of, sorry, this is just dp of I and max. So like, how you are going to make this table? So yeah, this is like a 2D table. What I can do is that make some table like this. dp of this is this and this. This will be size of n, so which will have values of 0 to n minus 1, and this will have two values, 0 and 1. So like the 0, it is giving max, and 1 will giving me min, right? Or you can also have some two different array. So let I just code, and you are going to understand this thing. more. Let's just say n is equal to the size of this nums. Now I will make the 2D vector dp of size n, and a 2D vector of, let's say, n cross 2, right? So yeah, it is going to be n cross 2. That's it. So a 2D vector which will have uh, n rows, and each row will have 2 columns, right? So now so the state is like dp of I0 is giving me the max value I can get in all of the subarrays ending at ith position. And remember this line, this is important. This is the subarrays ending at this ith position, right? So like you cannot take the maximum of all of the subarrays from this till this I, right? You because let's say the subarrays are something like this, and so you have some answer of this A3. So these are the three possible subarrays. So you can only then for A4 you can just expand this subarray, right? So you like, let's say you have some subarray like this. You for A4 you cannot expand it like that, or you cannot add A4 in this directly. So for this you only need to take the subarray which are ending at this point, which are only ending at this point. Okay, so NDP of I0, I1 is going to be the minimum or the max value with minus sign, right? Which is nothing but the mean value of all of the subarrays. Yeah, just that's it. Okay, just take these things. Now we have to think of the base case. What is the base case? So yeah, we have to count the value for the, I mean, answer for the first one only. So yeah, the max and min both are going to be just this case. So this is only min and this is all on the max we can have only. Then we will just loop in all of the I mean things, and now I have to count this thing. How are the transition are going to be look like? So dp of I and 1 is going to be maximum of these three values. What three values? So the one option was you take only the ith one, only the ith element, because the subarray of length 1 is also possible, right? And you have to see for it. Or what you do is that, or you take the maximum of the I minus 1 and you multiply it with the current one, or you take the minimum possible, or the maximum possible with minus sign, and you multiply it with the current one. That's it. And now again the minimum one, I mean the, sorry, this was I0, yeah, this is I1, and this is going to be the minimum. That's it. And now our answer, what is our answer going to be? So let's take the answer is equal to 0. And do we have to, so that, okay, so I think I have to take at least one. So let's just take the answer is this, and then for int I is equal to 0, I less than n, I plus plus, The answer is going to be the maximum of all of this range, right? All of this answer. Because like, okay, let me just clarify it here from in the tablet. So let's say we have two ones, this one, right? So now dp of 1 is showing me that the maximum answer for all of the subarray which are ending at this a2. Then this this dp of a2 will give me the maximum answer from all of the subarrays which are ending at this a2. Then the a3 will give me the maximum subarray, a maximum answer which are ending at this a3. A4 will again this 4 subarray, maximum of this, and so the answer is going to be the maximum of all of them, right? Because the subarray can be ended from any of this position. So it is just I have to take the maximum one. So maximum of answer and dp of I and 0, and just return the answer. Okay, I hope that is correct. Okay, I did some mistake here. Okay, it was 0, not I. Yeah, it was the first 0th element. Okay, I got the wrong answer. Oh shit, how is this possible? Okay, I did some error here, some error. Now to see what is the problem in this case is answer is 2 here. Okay, let me just see here. I can't find my problem in this case. dp of 0 1 and are calculated. These are also calculated maximum. This and dp of I minus 1 0 and this, which is the premax and the premix, something like that, and this, and this is just minimum of this. My answer is first nums of 0. Like I take whichever is the max one. I just loop and oh sorry, answer shit. Answer is equal to maximum of this. Shit. Sorry for a mistake. Answer is maximum of all of the values of this dp of I0. Okay. So yeah, my time complexity will be nice, but space complexity is going to be bad, right? Why my space complexity is bad? Because I'm storing all of the like big table. Instead of this big table, I can space optimize it and okay, you just think how should we space optimize this one. This is yeah, again very easy, because for like storing the value of each table, I only need to have the values of last two numbers, but that's it. So I only need the values of last two numbers, so I can just have that easily, very easily. So I can count this thing again easily. So instead of this dp, what can I have is that, let's say int last min and last max, and let's say global or just answer. So now the base case is going to be that the last max is going to be nums of 0, and the last min is going to be the again nums of 0. Now here let me have something like d max and d min. So now this d max is going to be this, d min is going to be this, and instead of this, like the max one, I have the last max, and instead of this I have the d min, sorry, the last max, the last min. I will do that here also, last max and last min. I hope that is correct. And now answer is equal to maximum of this d max and answer. Okay, again here answer is equal to, let's say, nums of 0. Now what I will do is that, let's say, okay, so what I did is that, let's say I was counting the values at this dp of at this first index, right? I have these two values, to the last min and last max. I calculated these two values and stored it in this d max and d min. Now when I go to this two, I know that this d min and d max are going to be the last min and last max, right? Okay, so like now here, what I will do is that the last max is going to be this d max, and this last min is going to be the d min. And now I will just ignore this case and return. Now you can see that my time complexity is of n and the space complexity is of 1 only, because I have two variables only, right? And just see, the runtime is only 0 millisecond, and my like this thing beats all of the case. Did I just make, okay, no. Okay, yeah, so I hope that you understand this question and also how to optimize the time and space complexity. Okay, not this one. Okay, let's now solve this case, and this is again a nice question to find what are the transition and this stuff. This is my personal favorite question in this one, and you are going to like solving it. Okay, so let's read the question, which is removing digit, and we are given an integer n, and on each step you may subtract one of its digit from the number. And how many steps are there required to make the number is equal to 0? Okay, so again pause the video and think for some time. Think if greedy is applied or not. Okay, or if brute force is applied or not, and something like this, all of the way. So let just and the n is still 26. All right, so okay, I hope that you have paused the video and think for some time. Now let me see the solution. The name of the question is removing digits. Right, so let's just see some test case, right? So before even before even making some assumptions that this is greedy or DP or binary search or something like that, you have to see one or two test cases, and then things and take some observation, right? And yeah, this is the main thing. Note that like before, just after reading the question, don't make assumption about the topic. I mean, sorry, this is wrong. Topic. So like by topic I mean that DP, greedy or something like this. So like, because the thing is, like, after seeing some question, people try to just think that, oh, in this question the DP is applied, and then they try to force the DP into this, right? They try to force let what state I need, but like, don't try to force it. Just take the observation and see which topic suits this question, and what how do you solve this one. That's how you have to see. Okay. So now we just take some test cases and think. So let's say the number is like 29. What you can do is that you can remove 9 or the 2 from this, right? So like, you can remove 2 from 29, or you can remove 9 from 29. So 29 minus 2 is going to be 27, and 29 minus 9 is going to be 20. Then again in this, like, there are also two ways: remove 2 or remove 7. In this also two case, remove sorry, there is only one case here. You can remove only 2. This will give you 18. Here also there are two case. It will make 23, 20. It will make 18. Or, like, yeah, you can see that there is a big subtree. But in this subtree, you can see that there are many things you are calculating. Like, these are overlapping, right? You are calculating this big thing of 20 here, like the number of ways to reduce from the 20 to 0. You are calculating it here also. You are calculating it here also. You are calculating it here. So you are just counting one thing many times, right? So it is the case of overlapping subproblems. So that's how by just seeing the observation a test case, I can think of that the DP will be applied, right? Or let's say you just did not take this test case and just think that, oh, greedy way can be good. Greedy way can be good. What is the greedy way? You will just remove the maximum one. I mean, remove the max one. Oh, sorry. This was not the case. Right? If the question has asked the minimum steps to reduce the number to 0, then there will be some greedy way you can think of. But after you take some test case, you will find that this greedy way is not correct. So that's how you have to think. And here I have to find that the case of overlapping subproblems, and now I have to think of DP. So now, what should be the DP on? Again, like in the number of ways, DP of I is simple. It is fundamental that like number of ways to make 0 from number I. Now what is how the transition will look like? How the transition are going to be look like? So let's say you have some number. The number is 162. So where you can go from this 162? So you can see that you can go to 162 minus 1. You can go to 162 minus 6, or you can go to 162 minus 2. So these are the three possible transitions, right? So now you can see that. So from this, the DP of 162, I mean the number of ways to reduce like 162 to 0 is going to be DP of 161, which plus DP of 150, 156 plus DP of 160. Yeah, that's it. Can you understand this thing? Because like let's say when you if you like see that uh okay, sorry. Right, so like from 162 you can go to this. You can either go to this or go to this. There are all the possible three ways. And if you have to find the all possible ways, you will do sum of them, right? That's it. So this is the thing we will do. So now the transition is going to be important in this case. The state was easy in this question, but the transition is nice. So what you will do is that you will see all of the digits of the current one, and then you will just do the number minus the digits. That's it, something like that, right? And you will get the answer. So let's just solve it by what? Okay, I hope that you understand this thing, right? Let me just okay, this is login. Oh, How many steps are required? Again, let me just we can try to do this with the tabulation way, right? By the recursion way, it is very easy. Now let me just solve it by try to solve it by the tabulation way. So in this, we have to go from the like bottom to up. So you will count like dp of 0, then dp of 1, dp of 2 till some dp of n, right? So let's try to do the code of this one. Let me remove all of this stuff. Let me write using ll is equal to long. So what we are given is the n, just n. I need to find the number of possible ways to like reduce n to 0. So it is easy. We will make some vector of dp of length n. That's n plus 1. And let's say the number of ways are 0 initially. The base case, what is the base case? Base case is going to be that. Like yeah, like you also have to think of this base case properly, because like in many questions the error can be in the base case, and you will see in the like when you solve the moderate to hard level question of dp, you have to properly think of the base case and how you will traverse in the dp. So like in initially, like what are the number of ways to go till the 0? It is just 1, not 0. Think of this, like if you cannot solve it. Now for int I equal to 1 to I less than n, I less than equal to n, sorry, I plus plus, you will do. Now comes the main part. How do you transition? How do you transition? So like you have to see all the digits of the number, right? And then you have to subtract it. So first you have to find this. You have to find all of the digits. Okay, how you are going to find that? So I hope that you know this thing, right? Because let's say this is the algorithm is simple. Because let's say the number is 1, 2, and 5, 125. So then 125 modulo 10 is going to give me 5. Then I will just divide it by 10. So the number is 12. Again, when I do the modulo 10, I will get 2. Then I will again divide it by 10. I will get only 1. And this modulo 10 is 1. So like I got all of the digits, right? 5, 2, and 1. That's it. So I will do it. So let's say the number. There may be, I think I should use LL everywhere. Long, because maybe the number of ways can be greater than 1 in 9. Like maybe that is a possible way. So let's have the value is equal to, let's say 0, and let's say the D answer is equal to 0. Sorry, the value is I. Now while I is not equal to 0, again there is also one case. One other problem is that, okay, what is the problem by this method? Okay, let me just do this and you will say that what is the problem with this method. Let's LL and the digit is equal to just I modulo 10. Then if the digit is not equal to 0, you will just do the D answer that's equal to, let me write here, val, because I cannot change in this I, right? Because then the loop is going to be changed. Then there's dp of this I minus dig, and after that I do the dig, sorry, the val divided by equal to 10. And now the dp of I is going to be this D answer. That's it. Okay, so now you have to say me, and the answer is just the dp of n. In this method, you have to tell me what is the wrong in this case. What is the wrong? Think of this. Yeah, the mistake I did in this, it was like, let's say my number was 112. I know that I can go to 112 minus 1 or 112 minus 2. But whenever I see the digits, like I see the 112 times, right? So I'm going to add the dp of 111 this two times, right? Because how my let's say I is equal to 112. Okay, so what the thing is going to be is that so initially the var is equal to 112, right? Let me write here. So initially the value is equal to 112. So the digit, which is 1112 modulo 10, the digit will be 2. So I do that d answer plus equal to dp of 112 minus 2, which is 110. Then my val become 1 1 only. I divide it by 10. So my digit is equal to 1. I do the answer plus equal to dp of 112 minus 1, which is 111. Then my val become 1 only. Then again the digit is 1. The d answer plus equal to dp of 112 minus 1. So you can see that this thing is adding two times, right, for the one thing. But I don't. I only need to add this dp of 111 only one time. So yeah, this was the problem. So what can I do is that let's just have some vector int of, let's say, frequency of size 10, or let's say used or not of size 10. So now if the digit is not equal to 0 and also it was not used, it is this digit is not used, this is also 0, then only I will use it and count it, and then used of dig plus plus. Like I hope you understood this thing, right? That's it, and I hope that this is correct. Yes. So when n is equal to 27, the output is 5. Sorry, where is the VS code? It is here. When the n is equal to 27, oh shit, I did some mistake again. Why the answer is pretty big. Why the answer is pretty big. Okay, so I think I have done some error in this. So okay, I have to check again. So n is equal to 27, the dp of n plus 1, which are 0 initially, and value is equal to I, the answer. And for each I make this used. The value is equal to I, the answer is equal to 0. And until this value is equal to 0, I take the digit. Then, if the digit is not equal to 0 and that digit is not used, I will add that into the answer. What is this? It is how many steps are required. Okay, oh shit. I did a mistake to read the question. This is just a minimum number of steps. Okay, I thought of the all of the possible steps. Okay, so apologies for my mistake. But it was also a nice question, like how many ways are there? So now let's say you have to think of the minimum answer. What is the answer is going to be look like? It is easy. It is easy. So you just have to do the min here. So let's say you just initialize this number with a with some pretty big number, and now it is just that minimum of the answer, and in this case, that was easy. I don't have to use the used here also. So let me remove this case. Okay, so yeah, so you, oh shit, again I did some mistake. Sorry, 1 plus. Okay, yes. Not 27 is equal to 6. Okay, it should be 0. Yeah, it takes 0 moves. That is nice. So, like in the, if you have to find the answer of all of the possible ways, you have to just sum. But if you want the minimum, then you have to just count the minimum only, right? So that's it. I do. Instead of just adding, I do the in this case, and it takes one move to come from this I minus digit to this current I, right? So that's it, and that is the solution. So let me submit it. Okay, that is the answer. So now it is your homework to optimize space optimized it. And again, oh sorry, it is going to be slightly tough because you know that what are the previous states you need. So there are 9 states that you may have need, right? Because let's say the digit was 1, you do minus 1, digit was 2, you do minus 1 till the the digit was 9 and you do minus 9. So again, yeah, there can be 9, but so it is tough to, I mean, slightly tough to space optimize it because you have to take care of 9 different values previous. That's it. So now try to find the time complexity and space complexity of it. Again, so the space complexity is easy. Space complexity is, it is going to be O of n, O of n. Now what is the time complexity? So like for each test case, I mean state, for each state, how many transition you have to do? Like so there can be 9 different possible values, right? So it is going to be n into 9. So like how to find this, that how many states are there and per state how many time it takes to find the value of this state. So like there can be 9 possible different cases. Okay, but initially the there can be, so n is still 1 is 6. So there can be only 6 digits. So 6 different digits. So yeah, this is going to be n into 6. Exactly, but yeah, you can write it as O of n only. So that was it. That's easy. So I hope that you understood this question, and this was a nice question. Like you have to find the transition. Okay, and so we discussed 3 questions. One of each different platform, and I give you this 3 question in homework. This is my favorite one, and in all of the 6 questions, this is my favorite one. Try to think of this question. This is an okay. Let me give you a hint. Instead of DP, like storing DP as vector of integers, it will have the DP as the map of something. This is a nice one, and let me like just please try to solve this question. And if you can't solve this, please write me in the comment. But yeah, after solving this question, you are going to learn a lot from this. So you are going to just conquer the 1 DDP. That's it. And again, these two also are a nice question. This one is also a good one, but okay. So that was it in this video, in this lecture. And if you can't understand something, or if you have some doubt, please let me know in the comments, or if the and please give me some feedback of how the lecture was. So that was it, and meet you in the next video.